되는 거예요? 동영상은? 이
네. 네. 아. Okay, I will start my presentation. My today's journal club topic is about SVGThinker, instruction aligned and reasoning driven text to SVG generation, and it's a paper published in 33rd ACM International Conference on Multimedia at 2025 October. And first, about introduction, the SVG is a scalable vector graphics, an image format adopted in modern graphic design. The vector image is a image file that represent graphic through some geometric entities rather than pixel grids like the more common image files like PNG or JPG. The merits of the SVG is about resolution independency and structurally editable. They are represented as a hierarchical XML-based code, but they are hard to understand its syntax or master the creation method by human. And the visual representation and semantic information of the codes are very complex. So there are some existing approaches as there are many of them, but they have some limitations. There are widely two groups. So one is optimization-based method, which generate image first, then optimize the path into them. They produce redundant and chaotic path structures, and they lack structural and semantic interpretability. They are also poor. They are very not good for addition after the creation. And second one is autoregressive approach, which use LLM directly generate code. They sometimes restricted for some of the vocabularies and fail to model the complex hierarchy structures, and they have weak alignment between text and the primitive level construction. The motivation of the paper is that existing methods consider the SVG generation as image approximation or direct code prediction, but they are all ignoring the reasoning process behind the visual construction. So the idea of the paper is that the generation task should be step-by-step reasoning process aligned with how humans construct graphics. So they should learn how to draw a graphic and align the semantic description with each drawing path, and the file should be generated explicitly by the reasoning before writing code. So the main contributions of the paper is the SVGThinker, which is a LLM-based text-to-SVG generation model. And they also come with annotation pipeline for the reconstruction of the hierarchical structure, and they give explicit alignment of the SVG primitive and its visual semantic meanings. They outperforms the prior SOTA models in the text and image alignment and coherence and editability. They collected the data from Kaggle and some free icon, which is called SVG repo. And so they collected 400,000 graphic data, and they manually calibrated the semantic matching accuracy of the data and the meaning, so to ensure comprehensible semantic coverage. And some excessively long samples were removed. And how did the others approach for the SVG reconstruction is they parsed the full image into structural elements. So they did these step-by-step approaches for each graphics. So, and they can be represented as these three structures. And so, and they will, and then they give annotation for the each steps of the graphic generation. So you can see, as in this figure too, each step of the drawing drawing is described as this each line, and they can be and after the all creation is done, there's also saved overall description of the full image and how they did train the model for the generation. So the goal of the training is aligning LLM's reasoning process with layer by layer drawing process. So instead of directly generating code, they make the model first formulate the structure of drawing steps, then generate the final instructions code. So they assume one image file is composed of sequence of primitive instructions, and then each of them, they have sequence of intermediate description and complete full description for them. So the first step of the training is the model predicts the intermediate reasoning steps conditioned on the TG, which is the final text description. And then the second step is the modeling of SVG instruction sequence, conditioned on each step description, and the model learns how to generate the corresponding instruction sequence. So following training that enabled the autoregressive training follows the autoregressive negative log likelihood loss function, which is used in many language models. And as the outcome, that this model can learn the sequential drawing logic of the image, and then it could understand intermediate visual construction steps, then generate the SVG code aligned with the structured reasoning process. Then they gave some comparison experiments with SOTA models to compare, then to highlight the proposed model's precise instruction editability and compare it with Sultan method. They use the backbone architecture, the Quen 2.5 and 7 billion model as a backbone, and it initialized with DeepSeek's chain of thought distillation weights with them. As for the comparison experiment, they used 200,000 text and pair SVG pair constructed from the annotation step, and 1,000 of them were randomly selected for testing. They compared the model with the closed source LLM like GPT-4 or DeepSeek R1 and other open source SVG generation method such as SVG Dreamer, Icon Shop, and Layer Tracer. As a evaluation metric, they used FID clip score and FID clip. For the result for quantitative comparison, the SVGThinker outperformed all baselines across all three metrics, and it demonstrated superior distributional similarity and text-image alignment. For the qualitative comparison, here's some example of the generated image from the paper. So SVGThinker does make the cleanest and well-structured visual, while image-based methods are